I'm not going to ask crazy questions. Thank you for being here.
Sure.
So I want to just give you 1 minute or so to introduce yourself, what you do, where you work, a little bit about your background,
Sure.
starting from this.
Yep. I'll start first. Mo Saleh. I'm currently a chief engineer at Oshkosh Corporation, leading the data team at Oshkosh Corporation. If you're not familiar with Oshkosh, it's a multi-segment heavy vehicles company from commercial to defense. Probably lately you heard the news where Oshkosh won the NGDV, which is the mail trucks. So we build a heavy trucks and specialized truck. My experience comes from academia and industry. I had a PhD in experimental physics. I done a lot of research in the analytics side at CERN, the European Organization for Nuclear Research in Switzerland. Thanks.
Cool. Please.
Hi, everyone. I'm Daniel Wu, head of AI and machine learning at JP Morgan Commercial Banking. At JP Morgan, I built a new AI team to drive our financial service transformation through AI innovation. I'm passionate about democratizing technology as well as the ethical use of AI. And this philosophy is shared through some computer science and AI/ML educational program that I've contributed to over the years. It's my pleasure to be part of this panel discussion, and I look forward to a very engaging discussion with my fellow panelists and you all on developing scalable AI solutions.
Cool.
Hello, everyone. My name is Ipshita Bhattacharya. I'm currently a senior imaging scientist at Roche. So Roche is one of the leading healthcare companies, and we have two wings, the pharmaceuticals and the diagnostics. So I'm part of a team that is responsible for developing computer vision and deep learning-based algorithms for several clinical workflow and image-based diagnosis. So for several cancer patients, be it from tissue biopsy or MRI or CT. And on top of that, we're also trying to develop our multimodal analysis algorithm suite. So where we use data from not only images, but genetics, sequencing, and we're trying to get closer to personalized healthcare with as much data as we can gather about patients. My background is in electrical and computer engineering, so I've got a PhD in EC where I focused on algorithm development, and prior to this I worked at National Institutes of Health where I worked on MRI and CT on different radiological images. So again, very excited to be here and looking forward to a great discussion with my fellow panelists. Thank you.
Cool.
And I'm Sam Fuller. I'm responsible for our AI inference product line at FlexLogix. I have a long history in computer architecture, engineering, design, business management from mainframes to embedded processors. So I've had a lot of experience with the architecture of processing, and this machine learning AI has always been something that has been of great interest to me, and I'm delighted to be able to work in this industry now and help push things forward.
All right, thank you very much. So the first question I have is, what's the difference between edge versus cloud? And in terms of the technology roadmap, and when and where you decide to go to cloud versus you go to edge, and anything involved with that, such as privacy, biases, ethics. So anyone want to just take that question?
I'll start here,
Okay,
just for the sake of it.
All right.
So I think whenever we say edge versus cloud, both of them are valid. That's the reason we're comparing them. When you think about it from any application side, I think if you're going to start with development, and to Sam's presentation, we have to separate the two in terms of the hardware when we say development and deployment. So whenever you do a development, I'm pretty sure cloud is your number one usually to go with. You do all these development using all this big infrastructure you have for your cloud. And whenever we get to that deployment part, that's where you start thinking about the edge. I think recently, if you look at Gartner charts, Edge also part of it, the edge analytics, it's currently at the top of the hype. Still emerging, you don't see much of these applications take into production or deployment just doing edge analytics. For pro and cons, I'll give just a short here, I'll give it to my fellow. I think many people talk about the cost. Usually the cloud costs all these infrastructure. Data privacy, sometimes people argue that edge is more secure. I think it can be, it cannot, because if you're dealing with, let's say our case, defense trucks, right? You don't want to keep that data on these trucks in case for these security purposes and so on. Then again, cost, security, and privacy sometimes, because if I look at an edge device example as the phones, right? You don't want to transfer that data from the phone to your cloud. So privacy is one of these concerns.
Anyone else? Any input?
I'll just say the fact that we're discussing we have a choice here is a good thing, right? Because you can just remember like a couple of years ago, nobody would be talking about deploying anything or training a model on the edge. It wasn't even possible. And so I think the fact that we're discussing it today is a good sign that the technology, both on the hardware stack and the software stack, and how we go about with model training and deployment have made quite a bit of advancement in the recent years. I will agree that because we have these options, we definitely need to look more closely at not just the cost, but also what makes sense, right? There's a very real concern over moving data around, and so having some sort of federated learning paradigm and allowing data to be sitting in where they are, well protected, and then have this more advanced learning paradigm definitely is a way of looking at how you want to structure both your training and your inference deployment side. And I'll just say it's really case by case basis. There's really no one single answer even within the same organization. There's some particular use case where you have very strong compliance and control. You are not allowed to move data into the cloud, period. And you even need to leverage on-prem infrastructure. So I think this is a very good question, but the answer can be very long and very case dependent.
Yeah. So yeah, just adding on to what Daniel just mentioned, so specifically for healthcare, what I can add is, again, sending data to the cloud is something that as a community we're not comfortable with, right? And a lot of work is being done in the field of federated learning to kind of mitigate that problem. So we have a lot of data sitting in different centers which are useful, and learning on cloud comes with its own problems. So right now, I think most of the work is being done on-premise, so models are deployed on-premise, but I think this is a valid question the community has recognized, and efforts are being made to see how it can be best utilized.
So let me have a follow-up question on that. At Roche, do you see any use cases that you could just bring edge to play instead of cloud or on-premise?
I think right away, I think we don't have a model introduction which works that way, but definitely, so for example, another thing with we have this online learning or continual learning framework, which in healthcare it's difficult to do because you have to go through regulatory approvals every time you want to change any of the model, right? So I think edge could be a great, replacement in that case, where you could have an intermediate model and then you can get the approval in steps and have something, if you have a better model, you have that deployed to work with. But yeah, we are not at that stage yet. And I don't think in healthcare, many companies have figured that out, because the FDA itself is looking into it, because to get a research-only algorithm, you can probably do that. But if you have something with FDA seal or CE-IVD seal, we need to think about these approvals.
Sure. Sam?
Cloud is defined by, or created, the cloud opportunity is created by communications technology. Without communications technology, cloud concept doesn't make any sense. But because of the communication technology, you have the concept of cloud. But clouds achieve, especially public clouds, achieve their business model by aggregating work from a lot of companies. So then that's what creates the concerns about security. And I know that they take it very seriously. They do a lot of work to try to ensure that your data is your data and that everything is protected. But obviously people still have concerns, and there are business model concerns. So I think there's obviously kind of the business model. Are you comfortable working with the service provider? Sometimes they can actually make your job a lot easier because of the services they can provide. But there is always a communications piece that has to be factored into it, because communications is its own business, right? It's not free, and then you need to look at, does my application run? I think everybody needs to look at their applications and decide, edge versus cloud, on device versus remote. And the answers will vary based on what it is you're doing. I think both are going to be important, and I think technologically we have to be prepared to be able to support both kinds of technologies.
Yeah. Before we move on, what would you consider to move your models or your data from cloud-based training to edge training? What are those kind of cautious items that you consider? When those are met, you would say, okay, this application or this model is not fit for cloud. Now it's time to move it to the edge.
Can I?
Yeah, sure.
Let me, on that point, when we talk about the edge training, I mean, one of the real values about training in the cloud is that you can kind of centralize and then distribute to the edge. When you talk about edge training, then I think you need to start to talk about how do you federate that, because you don't necessarily just want to learn something in one place. You want to be able to transfer that knowledge to other things. So that's one of the, I guess, complications of training at the edge, is that you should include some federation capabilities.
Correct. That's a great segue to go to the federated learning. So when for the first time I bumped into federated learning topic, I was thinking this is something special to different way of modeling. Later on, I realized this is a workflow for fine-tuning. How do you define federated learning? Whoever feels comfortable, take that question. Ifshita?
Yeah, sure. So I guess simply put, you have, let's say, several hospitals with data, right? And they all have their own model. Again, each hospital has their own distribution, so their model works on that distribution. However, we would like to have a centralized model which could have access to all this data, and we could have trained together. But since that is not possible, instead of sharing the data in one place, what we do is share the model from different institutes and bring them to one place and come up with an aggregated model. And this gets done in a sequential way till we have a model which is robust enough, right, that has consumed all the knowledge from all these different hospitals and is hopefully the best model that we have.
Great. Daniel, any point?
Yeah, I think in general that's how it works. But coming back to whether you can get that to work for the problem you're solving, that's another kind of big challenge to get this to work well. I think there's iterations of experiments and trying it out. Specifically, if you talked about a significantly different distribution in your data used locally for training, and then you try to somehow consolidate all that knowledge in one place, have this Uber model that's able to perform as well as these very specialized model. It's definitely a challenge, and it takes quite a bit of, I guess, learning, pun intended, learning by the team and learning by the actual technology to actually get it to a place where it's very reliable, that can give you that kind of performance that you're expecting.
Cool. Sam or Mo?
Yeah, I'll add the point here to Daniel's point. When you're talking about these federated, you start seeing these edge cases more often gonna appear because you limit yourself on that federated stuff. I'll add just one more point about the analytics side. You see a lot of these models, let's say mixture models, they try to do both, I think, in terms of a hybrid approach, where you take all these distribution and you add it all together and find some term that's applied to everything, and then take it back to the edge or these devices, separate devices, and try to learn. So it's a mix of what's the general behavior from all of these, and then define of just this is defined for this exact device or edge.
All right, so let me combine this. So now we have edge versus cloud and federated learning. So do you envision a use case at your projects or company that you are involved with to implement a federated learning using edge compute? Making it difficult.
I'll beg out of it. I mean, from my perspective, I'm really focused on the inferencing as opposed to the training and the learning. You know, I think at least what happens is you know, at the edge, you're like, I don't know what this is, right? And then you have to go back to something that's perhaps at a higher level to either, you know, federate that or go to a cloud or do something.
Sure.
As you reach those areas and then we essentially depend on being, you know, infused, right? Get the thing in the back of your head and learn how to fly the helicopter, right? It needs to drop down into our system to update the learning.
Any other inputs?
So one application I can think of, kind of like, for example, when we have models trained for a certain patient population, right? But when you deploy it in certain like regions, the ethnicity, and there might be some minor differences that your model hasn't seen, right? So you could have a federated learned model, which probably is a more generalized one, but you could still fine-tune your model for that particular region or hospital that you're deploying it to make it better suited in an edge training way, right? So yeah, you can, for individual models that can be done in a fine-tuned way, but the federated learning would still have to be depend on all the other data.
Sure. All right, so the next question is, we all have been facing the problem of scaling our AI models, but the challenges have been kind of different for each of us. Could you share the challenges that you went through and share with our audience here?
Sure, I can start here. Scaling AI is kind of very difficult and different, I'll say, from other problems or technologies. If I look at the factors, you have the hardware challenges, you have the software or the model, and all of these will contribute to just that scale AI to be difficult. We see a lot of places where they see that define the unexpected behavior, which appears much in the AI word. And then if I look at it, there's still much of these concerns in terms of data security again and data privacy. All these challenges you have, it's going to contribute to scaling that AI. But let's talk about our more of a applied to our places. That I always say the technology is easy, but the process is hard. If I look, we have a lot of technology regarding building a model, right, and then deploying a model. But trying to integrate these two solutions, it's not as easy as just plug and go. For our cases, deploying or scaling this AI. The hardware is one of these very important problem, which is whenever you want to put it on the edge, many times whenever our team wants to deploy it, we have to use our embedded software team. And the first term they say, we don't need that complex models, right? Because it's very hard to integrate. They look in all this decision tree because you can't interpret this, code this. So the deployment piece, which I always say, it's whenever you begin, keep the end in mind. That's very challenging these days for that deployment part to get to that place and deploy. And now on this talk, I had a question, how to deploy, right? Use Scale, use Nucleus, how to deploy back whatever you learned, whatever you've done, just to the edge or even to the cloud. I'll give it Paul.
Yeah, so I can list like many challenges, and I think some of the key areas that we're going to touch on in today's discussion, right? So the first one, I think, definitely data. Still, AI/ML depends on data. It's data-driven these days, and so data is a challenge, and data challenge both in quantity and quality. I think everyone here probably have the first-hand experience with like poor quality data or extremely skewed data set where you need to the solution that you develop is very hard to perform up to your expectation or generalize well, or even evolve as fast as the world evolves around that solution. So data is definitely one. Scalability on data is a huge challenge, at least in my domain, right? JP Morgan is the largest bank in the United States. The scale that we operate on is world scale, and how do you deal with that larger scale data and push that data set through your training pipeline in an efficient way and outcomes a high quality model is a constant challenge for us especially when that data keep evolving every day and you keep accumulating new data. So that's one challenge. The second challenge is compute. I think everybody here understand that compute is always a struggle, and that's why we're talking about whether you're doing training in cloud or on edge or doing some kind of combination on-prem, et cetera. So compute is a real challenge as well. Thanks to cloud technology, and now we have multiple major CSPs, so you can kind of do compare shopping and build a platform with multi-cloud technology. So you both have the scale that you need, but you also have that sort of fault tolerance and then backup plan that you need to run a sort of reliable and robust solution for your organization. I think the third challenge I want to point out, I think we here will dive into more detail, is about talent, right? After all, you need AI/ML talent to develop your solution, and everybody here in Silicon Valley knows firsthand that how hard it is to recruit and keep your talent on the team and continue to develop them. And finally, I want to point out, not just in my domain, I think across the board, is in the ethics space and compliance and governance space. In the past, like even previous years, like folks really don't think about it. They focus on developing a solution in the lab and think, hey, using the standard data set we have, this sort of state-of-the-art solution now in place, we're ready to roll it out. But in fact, you're not ready to roll it out because you haven't thought really carefully about running this in the real world environment. What are the consequences? Have you really looked into the ethics space there? And for banks, this is a must-have. I would say like number one challenge for me and my team is to ensure every model we roll out has clear explainability. It's not just the right thing to do. The law requires it. Banks need to be able to explain every decision made by these automatic tools, and that had to stand in court when a decision gets challenged. So that's an additional layer of concerns that we have here. But I'm sure, like in health space and other space, this becomes more and more true as well.
Shida?
Yeah.
Sam?
Yeah.
Go ahead.
So yeah, great points made already. Like for example, data is a big piece in scaling any algorithm. So a lot of times we kind of struggle to get representative data for any kind of patient cohort, and then how do we define representative? That's also a big question. Like what kind of factors should you consider to have a data set to say that it's good enough to train and deploy? And again, a lot of deep learning or AI models are brittle that way. So let's say you have trained your data with MRI from a particular vendor. It might not work that well when you deploy it or use it on data coming from a different vendor. So all of these considerations have to be made, and that data has to be gathered. And on top of that, the clinicians want to understand what the models are doing to approve them. So explainable AI is a big push these days. And again, with deep learning and computer vision methods, explaining everything is not that straightforward. So you have to go, you have to do find a other way to figure out or explain why a model is behaving that way. So that kind of limits you in what models can be used and deployed as well. Yeah, I think, and again, I think hardware and compute-based challenges are, I think, very similar to the other industries as well. So you want to be able to process large-scale data with low latency because you're trying to help with the clinical workflow. If the patient, I mean, our clinicians can do it manually faster than the model, that's no good. So yeah, all these considerations kind of are probably the biggest challenges at this point.
That's really interesting because explainability is not something that I didn't know people had to worry about, but the talent piece definitely is a problem everywhere. Trying to scale talent for these kind of technologies. One of the things that we think about a lot is just the scaling as we talk about the performance. You're trying to scale the capabilities of moving and processing data while you stay within a certain bounds of cost, power, dissipation, and whatnot. So a lot of the energy from a scalability perspective is how do you continue to improve performance, leveraging kind of a slowing Moore's law, and then there's a lot of looking at architectural information and really looking very deeply at the algorithms, trying to understand how they use the hardware, how can you grow the hardware, what if the algorithms change so that they use hardware differently. Because underneath all of this, unfortunately, is silicon, right? I mean, we have to have a silicon foundation that's able to support the software innovations. The software guys make a whole lot more money than the chip guys do, but we need each other in terms of making all this stuff work.
And I just want to add one more point which we face is a trust from your leadership and upper management. If you're sitting like us in the engineering department, which engineering is more applied, you have A, B to Z, that's all well defined, then giving to the leadership, we have an AI solution that can do this. I think this is a big challenge we have because of all these, there's no kind of measurable kind of metrics to say this is what you're going to get or so. There's a challenge to build that trust with the leadership. It's going to take time until you get to that place.
Sure. So Daniel pointed out to talent and retaining talent, hiring is such a daunting and difficult job, specifically in Silicon Valley area. So during the COVID, we mastered working remotely. And on the other hand, I know in a more regulatory kind of organizations, this is not allowed, or they are more sensitive with hiring remote resources. What do you think in terms of, I think JP Morgan and Health Department is the most restricted kind of companies. How do you overcome this issue and hire talent and retain them?
Yeah, that's a great question. And we actually learned a lot through the COVID, the now almost 2 years, right, with COVID. And we do offer, what we learned is we need to provide that flexibility for our employees. It's super important. JP Morgan does provide that flexibility to ensure that employees can take care of their family and themselves as well. We did go to the full sort of work from home mode, and now we're slowly since last year, late last year, start rolling, returning to office part-time. We haven't been returning to office full-time yet, and that's in North America. In the rest of the world, it's more based on the local health guidance, whether you should be opening up or not. So we're definitely compliant and working with local health authorities to make sure that our policy is in line and with the local situation. So for that, I think generally our employees are very happy with the flexibility they've received. There's absolutely, in terms of recruiting, almost every single candidate I interview with asks this question, like, can I work remotely? And I think it's a legitimate question on top of everybody's head, especially since COVID. A lot of companies already allowed permanently working from home. And so it's a totally legitimate question, but at the same time, we recognize that our business in terms of banking is very relationship-oriented business. Having that sort of human connection is very important. And also from some of the study that we conducted internally during COVID, actually employees wanted and craved that interaction with their coworkers. They felt like it's been too long that they only see someone on Zoom. And so that's kind of the feedback that we're getting. And actually when we started opening up again and having returned to office, people are very excited to have that opportunity to talk to their coworkers, their teammates in person again, and because everybody craves that connection. But I would say that we still have the flexibility. We're doing the part-time kind of hybrid model. And so we are just being very transparent with our candidates coming to us. We're very transparent in terms of why we're doing this hybrid model instead of permanently remote situation. So I think in my mind, as long as you're honest and upfront, and people will understand the reasoning behind the policies, I think it hasn't been a huge problem for me.
Great. Anyone else? If you
Not much to add. I think that at least the tech industry is definitely moving to a more hybrid model. There's certainly some roles that can be completely remote, but anybody who's working with any kind of team needs to have time together to be effective. And I think you're always hiring. That's the new reality of this world now. So.
Yeah, from my personal experience, I think hybrid is a preferred. I worked for a long time as a remote. Whenever you work as a remote, you lose that environment, the culture. Think about it. You work some people work more than 8 hours a day. It's part of your family whenever you work with your coworker. So it's good to see that face-to-face interaction, environment, and live it. Definitely remote has its pluses. Let's say if you not looking to relocate to another location, you can work for a company that it's on the West Coast where you're living on the East Coast. That flexibility is a plus, but I still see that hybrid environment and culture is a must.
Sure. Do you want to have any input, or you can open the floor for questions? You're the first.
I have a lot of questions.
Go ahead. You have 8 minutes.
I'm trying to separate it out between the different industries. I've tried to separate out the questions between the industries.
You got to turn it on.
First and foremost, is that it? Just the press? Oh. Can you hear me now?
Yeah.
So,
Hello?
what you can
We can hear you.
Yeah.
I am afraid if people.
Hello? Hello? It's on.
have to turn on the.
Okay.
We can hear you, and we can repeat the question.
You guys hear?
Sure.
Okay, great. Go ahead.
Okay, so let's start with the financial industry. Right? So financial industry has got a heckload of regulations when it comes down to cryptocurrency, blockchain, and all that kind of stuff versus the standard financial record. Right? So when you're deploying your AI models and stuff and working with the data, for the most part, you have structured data. So you can get a label and then have your model trained and stuff, right? But when it comes down to the different environments,
That's a great question. So I'll kind of divide up in two aspects. It really depends on the solution that we're building, what type of business problem we're solving. Some of our models were more universal, meaning that we have, like let's say JP Morgan offered this, several hundred different financial products and services, and they're applicable to like the global market or local market. That would determine how we want to go about this with our model training and deployment approach. There are certain restrictions. So there's very clear international data usage restriction that certain governments prohibit us from using those data to train our model solutions. So we comply with that. So because of these restrictions, certainly sometimes you just don't have a solution, or you can't use that data to train your model for a solution. So either way, we're complying with the local regulation about that, and depending on the restrictions we have, we'll have different type of solutions for them. More traditional sort of rule-based expert system is one approach where it offers good explainability because everything is prescribed by law or by regulation, so you're sure that there's no wrongdoing in terms of that decision engine. But for more ML-driven kind of solution, we tend to be very, very careful, just understanding what restriction we have on the data that we could use, and also the explainability itself. And also post-production monitoring is a big thing. We want to make sure that if there's any drift, data drift, concept drift, in the production environment, we will detect it and address it right away to make sure that we're always in compliance.
So inherently, explainability is not part of AI.
It's not.
Ecosystem, right? So I mean, the bottom line is we say we leave it to the compute mechanism to figure it out, right? Especially with unstructured data. But in coming to a different area, which is healthcare, one of the things is okay, hospital, you can centralize the data, right? That IBM was working on it, trying to pull all the data together from various hospitals. But from a Roche standpoint, you're looking at the pharmaceutical side of the equation, right? So accessing HIPAA-based data, if you want to call it, from the hospitals, to be able to then use it for private revenue generation from pharmaceutical industry standpoint, is that kind of workable from an AI standpoint, or you get only certain portions of data from your HIPAA hospital data?
So actually, the diagnostic wing of Roche, right, so works kind of in conjunction with pharmaceuticals to come up with these algorithms. So we do have a lot of collaborations in universities and hospitals where we build, let's say, research-only algorithms for them or any solutions for them. So a lot of our data comes from these collaborations and relations we have with hospitals or universities or academic institutes across the world. But yeah, I think that's a more business-related question. So exactly how this business is set up and how the other hospitals benefit from sharing data with us. But currently the model has been that we do have a lot of data coming from these collaborations. Also, we do need to buy data in some cases if we do not have access to that.
Which kind of makes sense.
Yeah.
Right. But from a diagnostic standpoint, so let's say you're talking about MRIs, fMRIs, brain-computer interface and stuff like that, the latest components of it, you're trying to get down to understanding the neurology aspects of it.
Yeah.
That, how do you work out the sharing or collaboration of the data from various organizations? Not, I mean, Roche is just one company, but you got Sanofi, you got other people, right? So do you share data so that you can come out with comprehensive diagnostics?
So like recently we have a collaboration with UK, so where Roche and many other universities and companies are working on so this is multi-modality diagnostics. So I specifically work on tissue pathology. So basically on biopsies, after patients have biopsy or resection, they have these tissue images, and you can do cancer diagnosis based on that. But there is other groups who's coming with, let's say, MRI or CT. So everybody's coming with their own expertise in some way, and then the goal is to reach a multimodal diagnostic platform, right, where you can have the best use of knowledge from every modality, or even other forms of data like EHR and others, and have the most constructive like diagnostic platform. But yeah, I think data, it depends on the application, exactly like how you can build these, but and it is of course a problem, and it's not, I wouldn't say it's completely solved, but currently that has been the approach.
All right, so we have one question from there.
So I'm going to quote Daniel, but the question is for all four panelists.
All right.
Daniel, you mentioned that compute is a challenge for training. Naturally, limits how much you can iterate. Is compute also a challenge for deep learning inference? Basically, the question is, does the lack of compute, or does the current systems, however much compute you have available, limit the inference that you can deploy? And do you guys need deep learning acceleration? And the question goes to all four of you again.
Yeah, so I'll start answering that question. I think in certain cases it can be, especially when you're thinking about training in the cloud, yet deploy your inference engine on edge. That, obviously that's a much smaller quote unquote sort of compute platform you have on the edge. So it definitely is more limited, and that could potentially also limit your choice of algorithms and the type of models that you build. So it definitely is a factor. To my knowledge, like our work currently is still very cloud-based, and so that kind of disparity between edge versus the cloud infra difference or capacity difference hasn't impacted us that much. But I can also see that it might come up later when we start rolling out, like our models to apps on, let's say, running on devices, and such things will come as a consideration for us.
Any other input?
Yeah, I'm just going to highlight the same way I said before. You have to begin with the end in mind. Otherwise, you're not going to be able to deploy it. And then the inference, most of our cases goes to the edge. So you have to limit yourself with the model that can be deployed on the edge devices.
Yeah, we have time for one more question. Yes.
Nobody else has.
All right. After this question, we break for lunch.
Okay, so talking about cloud versus edge, now this comes down to my area of interest, which is critical infrastructure, right, about the electrical grid. So what we have been challenged with is we have deployed all the IoT devices out in the field, then we gather the data, but there's a lot of real-time solutioning that we will have to do to be able to control the transformers and all that kind of stuff, right? So when we're doing that, a lot of the edge computing aspects of it is extremely important, because then you've got very low latency and you're able to then take action straight away. But on the other side of the equation is the cloud, where you can actually learn from a certain region and deploy it elsewhere, right? But how are you working through the migration of that information when you're talking about getting the edge learning into a model that's workable for all the regions in the cloud? I've always found that to be a challenge, because then you're relearning in a different cloud model versus what was specific to a region, right? So how do you do it in a different industry?
I think you're looking for a solution for your problem.
So that we can get some answers.
Yeah, quick answer, and then
On
you
the
can.
other hand, like, if
Yeah.
it's okay for reaching out, then we can take the discussion outside of it.
All right, okay, that makes
Yeah.
sense.
Yeah,
All right, thank you so much for
Thanks.
joining the panel, and really appreciate it. It was a great conversation.
Okay.
Thank you.
Thank you.